Okay, just when you thought it couldn't get any funner, let's talk about rationalizing. And in this case, we may be rationalizing the numerator or the denominator, or sometimes both if I really want to throw an interesting question at you. Rationalizing to remove a zero term. Whee! So, here's your example. Evaluate. Do I need to zoom in a bit? Am I too far out? Is that better? Evaluate the limit as x approaches 1 of x minus 1 over root x minus 1. So let's look at that for a minute. Let's allow the limit to do its thing. Let's go up and touch it. Bring da 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 ding, bring da 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 ding. X is now approaching 1. So 1 minus 1 is 0. 1 square root is 1. Subtract 0. Oh dear me. We have a problem, Houston. This is a problem. Well, if we're going to do this question by rationalizing, what you do is you multiply the irrational expression by its conjugate. And you've heard that word before. I know you have. Its conjugate is the same terms, but with the opposite sign between them. Because what you've created here is a difference of squares. I've got the a minus b and the a plus b, which means when they multiply, it's going to give me a squared plus b squared. And that squared takes care of those square roots. That's why this works. But if I'm going to multiply the bottom by a conjugate, I need to multiply the top by the same conjugate. Because what this is now, ladies and gentlemen, is this is effectively 1. It's the same thing divided by the same thing. So I'm multiplying this by 1, which means I ain't changing it. It's going to look different. It's definitely going to look different, but its value doesn't change because I only multiplied it by 1. So let's multiply. Now, let's be smart about what I multiply. Do I really, really, really want to multiply the top? The answer is no. You don't. I'm looking for my zero term. This is not a zero term, is it? As x approaches 1, there's no way that this is going to be a zero term. This is not my problem. This is my problem. So I don't want to multiply the top. I don't want to expand it. But the bottom I do, because that's the irrational part. So this is going to become x minus 1. Because just like I said, you've set up a difference of squares here. So I'm really hoping that you realize I can take the first term, square it, subtract the second square, and do it like that. Now if you need to, if you really, really want to, then off on another piece of paper, be my guest, start doing the rainbow method, and have fun with that. And by the way, I have no idea why they call it a rainbow. I've never seen rainbows that go up and down. What the heck? Who the heck thinks sees a rainbow like that? I don't understand this. Anyway, back over here. X approaches 1. This is my zero term on top. This is my zero term on the bottom. Bye-bye. What that leaves me with is the limit as x approaches 1 of root x plus 1. That is not a zero term because as x approaches 1, this is going to equal 2. And life is grand. Isn't that amazing? Isn't that amazing? I'll give you a chance to copy that down and then I'm going to blow your minds. We good? That makes sense? Okay, now I'm going to blow your minds. We lied to you in grade 11 and 12. I'm sorry. It wasn't me personally for any of you, I don't think, but had you been in my grade 11 class, I would have lied to you too. And we told you that you can only do difference of squares with perfect squares. And that was a bold-faced lie. So, let's look at this exact same question. I'll use a different color. Red is cool. Let's look at this exact same question. And let us be aware that differences of squares can happen even without a perfect square. X minus 1 is equal to root x minus 1 times root x plus 1. There's no problem with that. You can do a difference of squares without them being perfect squares. We completely lied to you. Look, I'm going to grab another piece of paper. Like, this is what I'm trying to tell you. This is so funny. X squared minus 25. Oh, that's a difference of squares, okay. X squared minus 7. Nope, 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 can't factor that. Nope, nope, nope. Yeah, liars. Why not? It factors. It absolutely factors. Oh, that's a difference of squares, definitely. Yup, yup, yup. No, that's not a difference of squares. Liars. Sure it is. Yeah, everyone in the studio audience is just looking at me. I think I'm in danger. Okay, so and this one. That's a difference of squares. You mad yet? Isn't that cool? Those are difference of squares, all of them. They don't have to be perfect squares to be factorable. So when I have the limit as x approaches 1 of x minus 1 over root x minus 1, yes, I can do it this way. I have no problem with that. But yes, I could also do a difference of squares on the top and get root x minus 1, root x plus 1, over root x minus 1. My zero term is the root x minus 1. Goodbye, goodbye. I'm going to be left with the limit as x approaches 1 of root x plus 1. Start the limit. Ring da da ding, ring da da ding. X is starting to move towards 1. So as x moves towards 1, it's the square root of 1, which is 2. Isn't that grand? I think I'm going to stop the video there and just see how things are going.